In this video, we'll solve several pediatric dosage calculation problems. Let's start with this simple one. The order is to administer medication Z 6,000 units IV 3 times a week. Patient weighs 25 kilograms. Safe range given for this medication, 500 to 700 units per kilogram weekly. Is the order safe? That's our question. Many times in pediatric math, you need to check after the physician if the order that is ordered safe to give to the pediatric patient. And usually there will be a safe range given. So how do we determine, is the order safe? This range is in units per kilogram. Our patient weighs 25 kilograms. Let's figure out what's the range for this patient. "500 units is for 1 kilogram. How many units is for 25 kilograms? I'm putting my units under units, kilograms under kilograms. Using DKP method, I'm going to multiply the two numbers on diagonal and divide by the third number to find my x. X equals 500 times 25 divided by 1. And that equals 12,500 units. I set my x under units, and so I'm getting my answer in units. That's my first number of the range. I do the same with my second number of the range. So do you see that we basically just multiplied 500 by our weight? We can do the same with the second number of the range. "700 times 25 kilograms. This is our second number of the range. So now we can see if we can compare the ordered amount to this range. Not yet, because take a look. The range is in units weekly. And the medication is ordered this many units 3 times a week. So let's bring it to the same time frame. 6,000 units 3 times a week. To bring it to weekly amount, we just need to multiply by 3. And we get 18,000 units. That is per week. That's what's ordered. Now we can compare. Is this order between these two numbers or not? Between 12,500 and 17,500. No, it's not. It is higher. So this order is not safe. In this problem, the order is to administer medication Z 6 milligram intramuscularly every 12 hours for a pediatric patient. Safe dose range is given 0.5 to 1 milligram per kilogram per day. The patient weighs 32 pounds and 12 ounces. The medication concentration available is 10 milligram per 5 milliliters. How many milliliters should the nurse administer? Let's first figure out our weight, because our safe range is per kilogram of body weight. And in order to compare our order to the safe range, we need to know how much our patient weighs in kilograms. I'm just going to rewrite the pounds and ounces that patient weighs right here. This is what we're dealing with. How do we convert this to kilograms? Let's first work with our ounces. We're going to convert ounces to pounds first. What do you know about ounces to pounds is that 1 pound is 16 ounces. 12 ounces, I'm putting ounces under ounces, is X pounds. Okay, 1 pound is 16 ounces, and I don't know how many pounds is 12 ounces. I'm going to multiply on diagonal, that's not an x, and I'm going to divide by the third number. So x equals 1 times 12 divided by 16, and that equals 0.75 pounds. I found pounds. Now I can add these pounds to my 32 pounds to find my kilograms. 32.75, that's the total number of pounds in my patient, is X kilograms. But I know that 2.2 pounds is 1 kilogram. Again, I'm checking pound and the pound, kilogram and the kilogram. I found my diagonal with two numbers that I can multiply, and I'm going to divide by 2.2. 32.75 times 1 divided by 2.2. And the answer is 14.88636 repeated. I'm not going to round this number yet. Rounding, if it's instructed to round in the problem, rounding has to be done at the very end. You do not round preliminary calculations. So our patient has this many kilograms. Now I'm ready to take these kilograms and plug them into my safe range. Is 0.5 to 1 milligram per 1 kilogram. What is it for my 14 and change kilograms? .5 milligram is for 1 kilogram. X milligram is for this number of kilogram. And I did not delete this number from my calculator. I'm just going to go ahead and work with this number right now. I'm going to multiply these two numbers, divide by my third number, and I get 7.44318 and change. That's my first number of my range for this patient who weighs this many kilograms. This is how many milligrams per day this patient can have. This is per day. Now the other number of the range is 1. 1 is 1. It's not going to change anything, so we're going to keep this number and say that my range is now 7.44318 and 14.88636. This is my new range for this patient who weighs this many kilograms. Now, this is daily range. What's ordered is every 12 hours. Okay, this is day. Now, 6 milligram every 12 hours. In 24 hours, we just need to double it and say 6 times 2 is 12. Is 12 milligram between these two numbers or not? Yes, it is. It's perfectly fitting in between. So this is a safe dose. See, even if we have only one question here, how many milliliters will the nurse administer? We still have to go through all of these calculations to determine, is this dose even safe? When we deal with pediatric patients, we want to be safe. So before you go to calculate your milliliters to administer, determine, is my dose safe? Now we know it's safe. Now we can plug it into our concentration. And I say 10 milligram is 5 milliliters. That's what's given to me. My dose is 6 milligram. Don't you take 12 milligram, because we only got that to compare it to a daily amount, right? So in a dose, we're not administering 12 milligram. We're going to administer 6 as ordered. So 6 milligram is X milliliters. I don't know how many milliliters is 6 milligram. 10 milligram is 5 milliliters. That's given. Again, I'm checking my milligram under milligram, milliliter under milliliter. Everything is set up well. I'm going to multiply on diagonal and divide by the third number. And my x here equals 6 times 5 divided by 10. And that equals to 3 milliliters I will administer to this pediatric patient. This is a very different problem. Here we're calculating daily rate of pediatric maintenance fluid for your pediatric patient. And the guidelines are given here how to calculate it. 100 milliliters per kilogram per day for the first 10 kilograms of body weight, 50 milliliters per kilogram per day for the next 10 kilograms, and 20 milliliters per kilogram per day for each kilogram above 20 kilograms of body weight. So our patient, Mary, weighs 43 kilograms. Let's figure out how many milliliters per day of fluid should Mary be receiving. Let's follow the steps. For the first step, we need to take 10 kilograms of her weight and multiply by 100. 100 milliliters times first 10 kilograms of her weight is 1,000 milliliters. Next line, 50 milliliters per kilogram per day for the next 10 kilograms. Do we still have 10 kilograms left in Mary? Yes, we used 10 for here. Now we use another 10 here. 50 times 10 is 500. How much do we have left in this patient? 43 minus 10 and minus 10, we still have 23 kilograms left. And that's what the third line is saying. At 20 milliliters times whatever is left over in the patient, basically. 20 times the 23 kilograms that are left in the patient. 460 milliliters. So altogether, these numbers add up to 43. We used 10 in the first line, first 10 kilogram. We used another 10 for the second line, and we used whatever was left for the third line. Now we need to add them up. If we add them all up, we get 1,960 milliliters per day. That's the answer to our problem. Now let's figure out the same problem for Lucy, who weighs 44 pounds. And as you can see, we can't use pounds here because our prescription is in so many milliliters per kilogram. So let's convert her weight to kilograms first. Using DKP method, I'm saying 44 pounds is X kilograms. But I know that 2.2 pounds is 1 kilogram. And I'm putting pounds under pounds, kilograms under kilograms, multiplying on diagonal, dividing by the third number to find my X. 44 times 1 divided by 2.2. And that equals to 20 kilograms. So my Lucy weighs 20 kilograms. Now I can plug it into my prescription here. So for the first 10 kilograms of body weight, I'm using 100 milliliters per kilogram. 100 times my first 10 kilograms give me 1,000 milliliters. Now, for the second line, I'm using the second 10 kilograms, the next 10 kilograms of body weight, and I still have something to use there. So 50 times next 10 kilograms is 500, and that's 10 and 10. I used up the entire weight. There's nothing for my third line. There's nothing to put in there. I'm just gonna add 1,500. And I get 1,500 milliliters per day for Lucy. And now let's figure out how many milliliters of fluids per day Tony will receive, who weighs 15 kilograms. Again, for the first line, I'm going to take first 10 kilograms of body weight. 100 times the first 10 kilograms give me 1,000. And then for the next line, 50 milliliters per day for the next 10 kilogram. However, I don't have 10 kilogram left in the patient. After I took the first 10 kilogram, I only have 5. That's what I'm going to put in a calculation. 50 milliliters times 5 kilogram that's left in my patient is 250 milliliters. Adding this up gives us 1,250 milliliters per day Tony will be getting. You will find more practice problems in my book, Dosage Calculations, Getting It Right Every Time.